Hi, hello everyone. In previous classes, I already spoke about the quantum mechanical model of an atom, which gives a clear idea about the structure of an atom. And I also discussed with you the Schrödinger equation. So, by the help of wave function and the Schrödinger equation, it helps to us the finding the probability of an electron. So, let us consider this is our atom. The probability of an electron means where we get the chance to meet the electron in this atom. So, where exact position of the atom. So, this is called as a probability of an electron. And I already told you by the help of 4 magic number, we got the exact or a probable address of an electron. So, in today's class, I wish to discuss with you the quantum numbers. It is a very interesting and very important concept in your second chapter. So, give lot of concentration, guys. So, see here, what do you mean by quantum number? Just I wish to ask your address. Then what you told to me? First, you said your state, and next your district, and next you will say your town or city, and then your house number. So, like that, your electron also have one address. So, like the electron state is main shell. Main shell is the state of electron, and subshell is district of electron, and next orbitals are the town or city of the electron. So, like this, the electron also have an address in an atom. So, by getting this address by the help of quantum number. So, quantum numbers are nothing but they are give an address of an electron. So, see here, what is the definition of a quantum number? The set of numbers used to describe the position and energy of an electron. Quantum numbers are used to describe the position and energy of an electron in an atom, called as a quantum number. So, we are having 4 quantum numbers. Those are, first one is principal quantum number. Principal quantum number. And second one is azimuthal quantum number. Azimuthal quantum number. And third one is magnetic quantum number. Magnetic quantum number. And fourth one is spin quantum number. Spin quantum number. So, these are all 4 quantum numbers, and these 4 quantum number gives an address of electron and the energy of electron to us. So, next we are going to study about principal quantum number. The first quantum number, that is principal quantum number. So, this principal quantum number is denoted by small n, and this quantum number or n is given by Bohr's. In our previous class, I already discussed with you the Bohr's atomic model of an atom. Then you learn about these orbits or energy levels or the shells, which is given by the Bohr and represented by small n. And next, the principal quantum number says, or it gives the information, or it describes the main shell. It describes the main shell or energy level of the atom. So, consider this is our atom. Consider this is our atom. In this atom, we are having the main shells. We are having the main shells. The principal quantum number says us to about the main shell or energy levels. So these main shells, these energy levels are also denoted by n. So what is the value of n? N is equals to 1, 2, 3, 4 up to infinite. The number of main shells is infinite. So these are whole integral values like 1, 2, 3, 4, and these are represented by, if n is equals to 1, this main shell is denoted as K shell. This main shell is denoted as K shell. And next, if n is equals to 2, then the main shell is denoted as L shell. Like this, if n is equals to 3, M shell. Next, N shell. K shell, L shell, M shell and N shell. So just if I ask the value of K shell, so that is 1. If n is equals to 3, then the shell name is M shell. It is our M shell. So once again I wish to repeat here. So values of n is equals to 1, 2, 3, 4, and these number of shells are represented by the name K shell, L shell, M shell and N shell. And next one is the number of subshells in the nth orbit. The number of subshells in the nth orbit. I already told you, in the atom we are having main shell. In that main shell we are having subshell. In that subshell we are having orbitals. In the main shell, how many subshells are present? In the main shell, how many subshells are present? So that is the number of subshell in nth orbit is equals to n. Means if in a first main shell or the number of main shell is equals to 1, then the number of subshell is also 1. In second main shell, we are having 2 subshell. In third main shell, we are having 3 subshell. So this is the meaning of this point. The number of subshells in a nth orbit is equals to n only. And next one is the number of orbitals for a given value of n is equals to n square. And next, so see here, in the main shell we are having a subshell. In that subshell we are having the orbitals, and the main shell number is equals to the subshell. We are having a third main shell, then the subshell is 3. The main shell value is 1, the subshell value is 1. Next, how many orbitals are present in this subshell? So see here, the number of orbitals for given value of n is equals to n square. Means if the main shell value is 1, our orbitals value also 1. 1 square means 1 only. If our if our n value is 2, then what happened? What is the number of orbitals here? 2 square is equals to 4. 4 are the number of orbitals for given value of n here. I hope you clear the points one by one. So next point is the maximum number of electrons present in the shell. We are having the shell. How many number of electrons present in that shell? So how much maximum number of electrons present in that shell is equals to 2n square. In a second subshell, in a second shell, we are having maximum 2 into 2 square means 4 to the 8. 8 electrons are present in second main shell. 8 electrons are present in second main shell. So this is the meaning of this point. The maximum number of electrons present in the shell is equals to 2n square. And next one is the orbital angular moment. Orbit angular momentum is equals to mvr is equals to nh by 2 pi. So this principal quantum number is given by Bohr. In Bohr's model of an atom, already was studied this angular momentum. So this we are finding the electron's angular momentum by the help of this principal quantum number, means the value of n. If we have a value of n is equals to 1, then the angular momentum is equals to h by 2 pi. If we are having the value of n is equals to 2, then what happened? 2h divided by 2 pi. So by the help of quantum number, by the help of this principal quantum number, we got the value of angular momentum of an electron. And next one, I already told you, by the help of these quantum numbers, we find the energy of the electron also. So this principal quantum number says us about the energy of electron also. So how it says the energy of an electron? As the number of shell increases, then what happened? Obviously the energy of electron increases. That energy of atom or that energy of electron is increases. So this principal quantum number says us the energy of the shell. And next one, explain main lines of a spectrum. So see here, already what is you are studied in hydrogen line spectrum. We are having some main lines like a Balmer, in the Balmer series and in a Paschen series, in a Fund series. So the principal quantum number says about or explain about the lines of a spectrum. Then we are denoted the energy levels by the n1, n2. So like this, the principal quantum number explain main line of the spectrum also. So this is all about this principal quantum number. Principal quantum number gives us information of electron all about this one. So once again I wish to repeat here, the principal quantum number says us or it describes us about the main shell or energy level of the atom, or the main shell or energy level of the electron. It describes the main shell or energy level of the electron. And next one, the values of n is equals to 1, 2, 3, 4, and that number of shells are represented by the names K shell, L shell, M shell and N shell. And next one, the number of subshell in nth orbit is equals to n only. We are having first orbit, we are having only one subshell. In a second orbit, we are having two subshell. So like this. And next one is number of orbitals for a given value of n is equals to n square. Then the maximum number of electrons present in a shell, n is equals to 2n square. So like this, in a second shell we are having 8 electrons, maximum 8 electrons. And next one is the orbit angular momentum, mvr, this is our angular momentum, is equals to nh divided by 2 pi. So by the help of this principal quantum number, we find the angular momentum of an electron like this. And next one is the energy of the shell. So this principal quantum number shows us to the energy of the shell. As the number of shell increases, then the energy increases. Next one is it explain about the main lines of the spectrum. So these are all information we got by this principal quantum number. Next one is our azimuthal quantum number. See here guys, what azimuthal quantum number gives information about the electron to us. So see here, the azimuthal quantum number is denoted by small l. Azimuthal quantum number is denoted by small l. Our principal quantum number denoted by small n and azimuthal quantum number denoted by small l. Here for the particular value of n, L is equals to 0 to n minus 1. So remember this value, L is equals to 0 to n minus 1. Our azimuthal quantum numbers value are start from the 0 to n minus 1. So see here, if we are having L value is 0, we are having the subshell S. S is our subshell. And next, L value is equals to 1, P is our subshell. And next, L is equals to 2, D is our subshell. And L is equals to 3, F is our subshell. So S, P, D, F are the names of subshell. How in the principal quantum number our main shell names or our main shell represented as a K shell, L shell, M shell and N shell. So like this, our subshell represented by the names S subshell, P subshell, D subshell and F subshell. So see here, I already told you, for a particular value of n, L is equals to 0 to n minus 1. If we are having n value is 1, then what happened? N minus 1 means 1 minus 1 is equals to 0. Our first shell, the subshell is 0 means S subshell. So see here, the next point, the number of subshells present in the main shell. I already told you, this azimuthal quantum number give information about the number of subshells present in the main shells by these values. And next one is the third point, relative energies of the subshell. It says the relative energies of the subshell. So means it says about the subshell S energy and it says about the subshell P energy and D energy, F energy. In the numericals, I will explain more about these energy levels. Just remember, azimuthal quantum number gives a relative energies of subshell also. It gives the number of subshells present in the main shell and it gives the information about relative energies of the subshell. And next one is, it says as the shapes of orbitals. It says as shapes of orbitals. Means, if our L value is equals to 0, then we are having a S subshell. This S subshell, we are having a spherical shape orbital. In a P subshell, we are having a dumbbell shape orbital. In a D, we are having a double dumbbell shape orbital. So like this says as the shapes of orbital also. In our next class, I wish to explain detailed about these shapes of an orbital. So now nothing to worry, just remember the azimuthal quantum number gives us the shapes of orbital also. Next, explain means the azimuthal quantum number explain the fine structure of a line spectrum. So this explain fine structure of line spectrum. And next, as in the principal quantum number, how we got the angular momentum of an electron, here in azimuthal quantum number gives us the orbital angular momentum. So we are finding with the help of this azimuthal quantum number orbital angular momentum of an electron. So this can be calculated by the formula mu L is equals to L into L plus 1 H divided by 2 pi. So this information says about the electron to us by the help of azimuthal quantum number. I hope you got clearance about this azimuthal quantum number gives us the information about the electron. So once again I wish to repeat here. So this azimuthal quantum number mainly says about the subshells present in that main shell, means which are those subshells. Those are S, P, D, F, and it is denoted by L, and this value are start from 0 to n minus 1. And next it gives a relative energies of the subshell also and shape of the orbitals by the help of these subshell. And explain the fine structure of the line spectrum, and it helps to find or it helps to calculate the orbital angular momentum of an electron by the help of this formula. Mu L is equals to square root of L into L plus 1 into h divided by 2 pi. And next quantum number is our magnetic quantum number. Magnetic quantum number, it is denoted by M or ml. The magnetic quantum number, it is denoted by M or ml. So what the magnetic quantum number says the information about the electron to us. So see here, it describes the orientation of an orbital. It describes the orientation of the orbital. I already told you the orbitals have different size, different shape in nature. So they are having different orientation also. Our electron revolve around the nucleus in a different orientation also in that orbital. So how it explain about the orientation of the orbitals? So see here, the magnetic quantum number value is minus L to plus L. It is denoted by a ml and its value is minus L to plus L. If the value of n is equals to 1 or L is equals to 1, then what is the magnetic quantum number value is plus 1, 0, minus 1. So see here, including 0, its value is minus L to plus L. So L is equals to 1, ml is equals to plus 1, 0, minus 1. So how many orbitals, how many orientation or orbitals we are having here? So see here, plus 1, 0, minus 1 means this is our x, dx, dy, dz. So these are the different oriented orbitals. So in the x-axis, or orbital may be in y-axis or orbital may be in z-axis. So these are the different orientations of the orbitals, and it says the number of orbitals present in a subshell also. And next see here, if the value is 2, if the value is, I wish to write here, if the value is 2, then what will become in a magnetic quantum number? Plus 2, plus 1, 0, minus 1, minus 2. Or you can write as like this also. How many orbitals are in this subshell? So 5. By this value we got these boxes 1, 2, 3, 4, 5. So like this, plus 2 means plus or minus 2, plus or minus 1, 0, plus or minus 1, plus or minus 2. So we are having the orientation like dxy, dyz, dxy, dyz, dz square, dx square minus y square, and next one is dzx. So dxy, dyz, dz square, dx square minus y square, and dzx. So these are the 5 types of orientations orbital we are having in our subshell. So this information gives by the magnetic quantum number. And next one is the number of orbitals present in any subshell. So see here, it gives the number of subshells present in any subshell. And next information what gives us to us, that is it explains the splitting of lines in a magnetic field. In a limitations of Bohr's atomic model, Bohr fails to explain the Zeeman effects, means our spectral lines are again splits up in a magnetic field or in a electric field. So he fails to explain that, but our magnetic quantum number explain the splitting of spectral lines in a magnetic field. Splitting of the lines in a magnetic field. So this information about the electrons gives us by this magnetic quantum number. Again I wish to repeat here, magnetic quantum number, it is denoted by M or a ML, and it describes the orientation of the orbitals to us, and this value is minus L to plus L including the 0. If the value is 1, then what happened? The plus 1, 0, minus 1, we are having the 3 orientation of orbitals here, dx, dy, dz. If the value is 2, we are having 5 orbitals, means 5 orientation orbitals, plus 2, plus 1, 0, minus 1, minus 2, like dxy, dyz, dz square, dx square minus y square, and dzx are the different types of orientations of the orbitals. And next one, it says the number of orbitals present in the subshell, and it explains the splitting of lines in a magnetic field. So this is all about our magnetic quantum number. And next one is our spin quantum number. Spin quantum number. Spin quantum number is denoted as S or denoted by MS. So what the spin quantum number says to us, see here, it describes the spin of electron. It describes the spin of electron. Already you know that the electron is revolve around the nucleus in a different orbitals in different orientations, and electron revolve and electron rotates its own axis. Just consider I am an electron and I am revolving around the nucleus, and as well as I am rotate my own axis, means I am rotating like this my own axis. So this is called the spin of electron. So this spin of electrons describes by the spin quantum number. And see here, the spin quantum number is denoted as, and the value is plus or minus half. Plus or minus half. Electron may be spin in the clockwise direction, or electron may spin in an anti-clockwise direction. But not the meaning like that the plus half is clockwise only, minus half is always anti-clockwise only, plus half is always clockwise. Not like that. There is no classical analog between the two spin quantum numbers. There is no classical analog between the two spin quantum numbers. So the quantum number value is plus or minus half here. And next, if we calculate the total spin, we write the formula plus or minus n by 2. Plus or minus n by 2. Here, not to confused about this total spin, n means not the principal quantum number. N is not a principal quantum number. Here, what is the n? N is the number of unpaired electrons. N is number of unpaired electron. If we calculate the total spin, we have a formula that is plus or minus n by 2. And next is, here the spin quantum number says about the spin angular momentum of electron also. Spin angular momentum of electron also. So the formula is the square root of S bracket means into S plus 1 h divided by 2 pi. So this h divided by 2 pi we can write h bar also. We can write as h bar or cut h also. The square root of s into s plus 1 h divided by 2 pi. Here the s value is n by 2. Here the s value is n by 2. N means, already I told you, the number of unpaired electrons. N means the number of unpaired electrons. So this is about the spin quantum number. The spin quantum number says us the spin of electron. Electron may revolve or may rotate in a clockwise direction and may rotate in a anti-clockwise direction. So the spin quantum number value is plus or half 1 by 2. There is no classical analog between the two spin quantum number. And next, the total spin is equals to plus or minus n by 2. Here n is equals to number of unpaired electrons, and the spin quantum number says about the spin angular momentum also. So the spin angular momentum formula is square root of s into s plus 1 into h divided by 2 pi. So here the s value is n by 2. N means the number of unpaired electrons. So this is all about the spin quantum number. So I hope you got a clearance about this 4 set of quantum numbers, means principal quantum number, azimuthal quantum number, magnetic quantum number and the spin quantum number. So this is mainly about the main shells like a K, L, M, N, and azimuthal quantum number says main about our subshells like S, P, D, F, and magnetic quantum number mainly says about the orientation of the orbitals, means minus L2 plus L or plus L2 minus L including the 0. And next one is the spin quantum number. This says about the spin of electrons plus or minus 1 by 2. So this is all about our quantum number. In our next class, I wish to explain about the numericals based on this quantum number. So those are very important to you in your NEET examination and JEE and JEE Advanced examination. On the topic of this quantum number, maybe or probability of one question is there. So thank you.